Assalamualaikum warahmatullahi wabarakatuh. We are going to present our mini project for ECE431, subject computer programming. The chosen topic for this project is traffic speed violation monitor. Here are the team members for this project. My name is Nur Aisyah binti Muhammad Suhaimi with student ID 2025140017, and my teammate is Nur Atia Sabirah binti Ramli with student ID 2025509165. So for the first part of the presentation is introduction. I start with the introduction of our project. Road safety is an important issue in modern cities, and one of the main causes of road accidents is speeding. When drivers exceed the allowed speed limit, the risk of accidents, injuries and loss of life increases. Because of this, monitoring vehicle speed and identifying speed violation is very important to improve road safety and support sustainable cities. So our project is titled Traffic Speed Violation Monitor. This project is developed using a C++ program to analyze vehicle speed data. The program reads traffic records from a CSV file which contains information such as timestamp, vehicle speed, speed limit, state and vehicle type. Based on this data, the system detects whether a vehicle exceeds the speed limit and then classifies the violation into minor, moderate or severe, depending on how much the speed exceeds the limit. This project also supports SDG 11, which is Sustainable Cities and Communities, as it helps authorities understand speeding behavior and improve traffic safety. Okay, next I will explain the objective of a project. The first objective is to read and process traffic speed data from an extended CSV file. This allows the program to handle real-world traffic datasets. The second objective is to detect speed limit violations accurately by comparing vehicle speed with the speed limit. The third objective is to classify the severity of each violation based on how much the vehicle speed exceeds the limit. The fourth objective is to calculate violation statistics such as the total number of violations and the overall violation rate. Finally, the last objective is to identify the peak hour when most speed violations occur, which helps in identifying high-risk time periods. All these objectives are achieved using basic C++ programming concepts such as structures, vectors, functions, file handling, and control structures. I'm going to present on the methodology part for this mini project. Okay, so for the methodology of this project, we use a well-organized function-based and manual driver C++ programming approach. This approach ensures that the traffic data is processed accurately. The program is easy to understand and maintain, and the output is meaningful for real-world traffic analysis. All the C++ concepts used in this project are selected to meet the project requirements such as file reading, violation detection, severity classification, statistical analysis, and user interactions. Okay, the first methodology is use of structure for data organization. Here we use a structure named traffic record to represent one complete vehicle record from the CSV file. Here I'm showing the structure definition from our project code. This structure stores related data such as timestamp, speed limit, state, vehicle type, and hour in one unit. Using a structure improves code readability, maintains data integrity, and makes it easier to pass vehicle records into different functions. Next, the second methodology is use of vector for dynamic data storage. We use a vector traffic record to store all vehicle records read from the CSV file. Moving on to the next methodology, which is file handling and CSV reading files. The program reads vehicle data from an external CSV file using file handling techniques. Here I'm showing the read CSV function. The file is opened using ifstream. Each line is read using getLine, and the values are separated using string stream. This approach ensures accurate reading of the file and keeps input handling separate from data analysis. Okay, the next methodology is time conversion using a separate function. The timestamp in the CSV file is stored in seconds, so we convert it into an hour value between 0 and 23. Here I'm showing the function getHour from second from our project code. Firstly, we divide the timestamp by 3600 to convert seconds into hours. Then we use the modulo operator, which gives the remainder after the division. Using modulo 24 ensures the hour value stays between 0 and 23, which represents a valid 24 hours time format. This function is written separately to make the code modular, avoid repeated calculations, and make debugging easier. Next, we have detecting violations, which a separate function is used to check whether a vehicle exceeds the speed limit. So if the speed is greater than the speed limit, the function returns true and the record is treated as a violation. After detecting a violation, the next methodology is classifying severity. The program classifies violations into minor, moderate, and severe based on how much the speed exceeds the limit. This classification uses simple if-else statements and follows the project specification. It helps us understand how serious each violation is. Okay, the next methodology is menu-driven program. The program uses a menu driver interface, so users can interact with the system. So I'm showing the menu from our program where users can select different options such as displaying all data, showing violations, viewing statistics, and detecting peak violation hour. So the menu is implemented using a switch case structure which improves user interaction and meets the minimum menu requirement. Furthermore, we have modular functions. Each task in the program is implemented using a separate function. For example, read CSV is used to read data, show all data displays record, show violations displays violations, and show statistics calculate the analysis. This modular designs makes the program easier to read, test, and also easier to maintain. So moving on to statistical analysis, the program uses loops to process all vehicle records and maps to count violations by severity. From this analysis, the program calculates total records, total violations, violation rate, and severity distribution, which it provides meaningful insights into traffic behavior. Next, the methodology is detecting peak violation hour. The program groups violations by hour and identifies the hour with the highest number of violations, which allows us to identify high-risk time periods, which is useful for traffic safety analysis. Finally, the last methodology is formatting output. The program formats the output into clear tables using alignment and precision control. So basically, this improves readability, makes the output professionals and suitable for reporting and presentation.
Okay, now I will demonstrate the result produced by the traffic speed violation monitor program. I will go through each menu option and explain what the outputs mean. For menu option 1, the program displays all the vehicle speed data that is read from the CSV file. So here each row represents one vehicle record. We can see the time spent in seconds, the vehicle speed in kilometer per hour, the state, the vehicle type, and the speed limit. This output confirms that the CSV file has been successfully opened and parsed. All the data is stored correctly using the structure and vector in the program. So the table format makes the data easier to read and help us quickly inspect the individual records. This step is important because it verifies that the input data is correct before performing any analysis. So next, menu option 2 will display only the vehicle that exceed the speed limit. The program checks each record using the simple condition, which is if the vehicle speed is greater than speed limit, then it is considered as a violation. For every violating vehicle, the program calculates how much the speed exceeds the limit, which is shown in the over columns. So for the severity, based on this overspeed limit, the violation is classified into 3 levels, which is minor, moderate, and severe. This This classification helps us understand not only how many violations occur, but also how serious they are. Several violations indicate higher safety risks compared to minor violations. So the menu option 3 show all the overall statistics for the dataset. From this result, we can see that 1,000 total records in the datasets, and 24 of them are speed violations. This given a violation rate of 2.4%, which means most vehicles in dataset follow the speed limit. The severity distribution show that the most of the violations are minor, while fewer cases are moderate and severe. This statistic provides a summary of traffic behavior and help us understand the overall compliance level. So the menu option 4 identifies the peak violation hours. The menu converts the time spent values into hour and count how many violations occur in each hour. In this dataset, the peak violation hour is identified as 0.00, with 24 violations recorded. These results show how time-based analysis can be identified high-risk period. However, since the time spent are limited in range, most violations fall into same hour. For real-world application, using actual time of day data would give more meaningful results. A menu-driven C++ program was successfully developed to analyze the traffic speed data from a CSV file. The system is able to detect speed violations, classify their severity, compute violation statistics, and identify their peak violation hour. The result demonstrates that basic data processing techniques can support traffic safety monitoring. Although the dataset has limitations, the project objectives were achieved and the system can be improved further in the future.